Okay, so we're continuing with this proof at theorem 3, and it looks just like the last corollary, but without the assumption, so it's just true. It's necessarily true there exists a y that's godlike. It seems to be the last theorem. That is the final claim. It's necessarily true. So in every possible world, there exists something godlike. So therefore, in the this, might be a different one for each possible world. It seems, but there probably would only be one. And then, okay. So anyway, let's look at this argument. We might have to make some sort of checklist of things that we don't understand and come back to them. Because look, there's lots of things. What's this? Becker's principle? All this other stuff. Okay, so let's have a look. Because of corollary to theorem 2. So corollary was that g of x implies that. Okay. So it seems like if we have that, we can just add a quantifier that's true for all x. Okay. Yeah, okay, so we didn't actually assume what x was to show that. So it's true for all x. Yeah, it's fine. From this we get, this is kind of a weird one. There exists x for which x is godlike, and that implies this thing. So let's have a look. For this to be true, if some x is godlike, then I guess that seems true from the corollary. Why do we have to use this step to get there? Why isn't it just true that if there exists some x for which g of x is true, then that's true? So the conclusion didn't depend on x, which x was godlike, so if there was one, then that should be true. I'm a little bit confused how it follows from this quantifying game. And then this necessitation we figured out was just putting this square in front of some statement that was true in maybe some particular way. So we put a square in front of this. Okay, and now we have modal logic theorem in K. You get this. So this looks like a distributivity thing, except it turns into a possibly once it goes inside the bracket, see? So how would it go? So let's assume this is true. So in all possible worlds, phi implies psi. They want to show this is true. Well, if it's true, we want to assume this. So assume that phi is true in some possible world. And then we want to show that psi is also true in some possible world. It doesn't have to be the same one, but it could also be the same one. So if phi implies psi in all possible worlds, and phi is true in some possible world, and then in that particular world, psi is also true. Okay. And so then psi is true in some world. So this is sort of like a justification for this kind of manipulation. We get, okay, so we just simply put that on the outside, inside, but change it into a diamond, okay? And then there's this Becker's principle that says anytime you have a diamond with a square, you can remove the diamond, okay? So we're not just undoing our hard work that we just did, because I'm assuming we're going to just remove one of the diamonds. Yeah, so it's the second one. Okay. So what is that? In some possible world, in every possible world, psi holds. Then in every possible world, psi holds. I guess that seems fair enough. Though it's a bit confusing what these two quantifiers mean at the same time when they're put together. It's possibly necessarily true that possibly necessarily true implies it's necessarily true. Possibly necessarily implies necessarily. Huh. That's like saying if something is possibly necessarily there exists some y that's godlike, then it's necessarily okay, so there exists some y that's godlike. Okay, and I remember seeing this before, so this is theorem 1 or corollary of theorem 1. See, it's possibly true there exists x that's godlike. So that's true. Now that we have that, and this is true, this is true. Oh, so I'm jumping a little bit ahead. So this is the one that we had before. So if that's true, then this is true. Okay, so then the conclusion is this. So this is the corollary. Okay, and why is this implication true? Well, hypothetical syllogism. I don't really know what that means. No, wait a minute. So we have this implies that, and that implies this. Yeah, I guess so. That's sort of what I would call what's this ABC logic or something. It's like this A implies B, B implies C, so then A implies C. It's transitivity of implication or something like that. So that gives you this final implication. That implies this. And then since this is corollary 1 or 2, whatever you want to call it, then this is true, and this is the thing we wanted to prove. So Becker's principle and this idea of quantifying is still a little bit confusing to me. But if you accept that, then we finish the proof.